Hello and welcome to this video where we will convert images like this into something like this. So let's get started. So in this video we will walk you through a Python script that loads a content image and style image, and we uses a pre-trained model to apply the style of the style image to the content image. So first let's take a look at the code. The script begins by importing several libraries including TensorFlow, TensorHub, NumPy and PIL. It also defines a function called tensor to image, which converts a tensor to PIL image object. This function is used later to convert the stylized image written by the pre-trained model to a PIL image. Next, this script defines a function called load image, which loads an image and resizes it so that its longest dimension will be 512 pixels. And this function is used to load both content as well as the style image. After defining this function, this script loads the content image and style image using the load image function, and it utilizes the hub model to convert and apply the style on it. So we have taken the look over the code. So let's talk a bit more about what's happening behind the scene. So if we go above, we can see there are a bunch of libraries. So we will go through this one by one. Matplotlib library is used to visualize the images in the graph. For our purpose, we are visualizing all the images using the matplotlib. Then we have this method, which is actually just defining the figure size as well as the grid for this one. And then we have TensorFlow Hub. So this library provides a way to load pre-trained models from TensorFlow Hub. TensorFlow Hub is actually a repository of all the machine learning models that is made by the TensorFlow. And we can use it and directly do some work on it and get a result. And then we have NumPy library. This library is actually used to perform numerical operations, numerical computations in the Python. Then we have pil.image. This library is used to load and manipulate the images into Python. So let's talk about the tensor to image. So this function multiplies the tensor by 255 to scale its value from 0 to 1. It will be from 0 to 25 to 255 from there now. And this increases because PIL expect the image data to be in the latter ranges. So therefore we are converting them to 255 only. Next, the function converted the tensor to an NumPy array of the unsigned 8-bit integer. This is necessary because the PIL image expect this format. And then we are doing an assert operation over here. So this will throw an error if the dimension of image will be greater than 3. Otherwise, it will just convert them to a 3-dimensional NumPy array. And finally, it will create an PIL image and return it. So now let's dig deeper into the load image method. So the method first sets the maximum dimension to be 512 pixels. And this represents that the largest dimension of the image, either the height or the width, will be scaled down to a 512 pixel. And then we are reading the image from the path, and then we are decoding it. Here the channel 3 represent the RGB channel, which is red, green and blue. Then we are converting the image to float 32 value. We are doing this because the neural network typically work with the floating point values. Then the function calculates the shape of the image as a float 32 tensor using tf.shape and cast it to float 32. The last dimension of here is sliced off because it represents the color channels which we have already defined above. Then the long dimension variable is set to the maximum of the image height and width, and scale variable is calculated as the ratio of the max dimension and the long dimension. Then the new shape variable is calculated by scaling the original shape using the scale factor and casting the result to an integer. The image is then resized using the TF image resize to a new shape, and a new dimension is added to represent the batch size using the tf.new axis over here. Finally, the function returns a tensor. So now let's move to imshow function. So it is a simple method that takes the tensor and as input and represent an image or result an image into matplotlib. So the function first checks if the input has more than 3 dimension. If it does have a 3 dimension, it assumes that the first dimension represents a batch of the image and squeeze it out with x is 0. This is because matplotlib expected 3-dimension image tensor with the dimension of height, width, and channels. Next, the function calls the plt.image_show, which with the input image to display it. This function displays the image as plot with pixels value representing by color. Finally, the function check if the title of the plot using plt.title. If the title is there, it will just put it on the graph or the image. Overall, this function is an utility function that allows us to easily visualize images in our code. Next, we are going to check. We can see that we have loaded both image using the load image function, and we are plotting it over here. In this code block, we are using a pre-trained neural model from TensorFlow Hub and apply the specific style to the given content image. First, we will load the pre-trained model using the hub.load. And then the model we are using is arbitrary image stylization v1. And this model is from the Google Magenta project, which is designed to apply a given style to an input image. Next, we apply the style to the content image by passing it through the loaded model using hub.module. And it takes the two parameters, the content image as well as the style image, which we have passed over here. The function returns a stylized image which we will extract using the 0th index, as we want only the first and only tensor which is returned into a tuple. Finally, we convert the resulting stylized tensor into the image, and then we are going to display this image. So the final output will be something like this one. So this style is applied onto this one, and if we want, like, we can save this image as well by .save method, and we can pass the whatever the name we want. That's it for the video. I hope you found it informative and useful. If you have any question or comment, please leave them in the comment section below. And don't forget to subscribe for more videos like this one.